Hello, in this series of videos I'll be talking about IK effects, specifically IK effects applied to arms, but the same techniques can be applied to legs as well. The things I'll be talking about are elbow sliding, Stretchy IK, Nonstretchy Soft IK, Stretchy Soft IK, and elbow pinning. So that's quite a lot of them, and we're not going to just be talking about them individually. We're going to combine them together into one control rig, and this is what it'll look like in the end. So there's two ways you can accomplish this in Maya. You can do it with expressions or with nodes, using the node editor for example. This one has been set up with expressions, and throughout the series of videos I'll be referring to the expressions, but I won't actually be doing it in the expression editor. If you want to know how to set it up with expressions, obviously you'll be able to see some of the expressions that I'll be referring to, but I'd probably recommend that you just have a look at the other series I did doing this exact same rig but in 3ds Max. They're surprisingly similar. So this, as I was saying, this is set up with expressions, and there's the Stretchy Soft IK. So everything works here, but we're going to be doing it with nodes. So this is the same scene, again, Stretchy Soft IK, same values in the channel box there. And what we'll be eventually creating is something like this. So this is all of the nodes combined together and placed on the lower arm and the wrist, and that's what we can get control over how they sort of move and translate in the X by playing about with these values here. We'll also go over how to set up the non-stretchy soft IK, and that's done with an exponential function, and that looks like something like this. So we have a long sort of chain of nodes put together, and then some conditional nodes as well. Okay, so that's what you can sort of look forward to. But before we get started on that, this is just sort of an introduction video, so I like to go over and discuss these effects individually before moving on. So I have a more sort of formal description of each one individually. So before I take that Word document over, let's actually see a few of them in action. So this one is elbow sliding. So elbow sliding just allows you to move the location of the elbow and then still have your IK affect it. Okay, so let's just drag this over. So elbow sliding works by simultaneously moving the lower arm and the wrist while maintaining the overall length of the bone chain. If the lower arm is moved so that the upper arm is elongated, then the wrist must contract so that the lower arm is reduced in size. So what does that mean? Well, the stretching of the upper arm, I'm going to refer to this as an arm, so this is going to be the upper arm, the lower arm, and the wrist is down here. The stretching of the upper arm is caused by its child, the lower arm, moving in parent space, which is, if we just do that way. Okay, so when we control the child moving in the positive x-axis with respect to its parent, it stretches the upper arm. To compensate for this, the wrist contracts, it moves in the negative direction in parent space with respect to its parent, which is the lower arm, and this makes the lower arm contract. So this maintains the overall length of the bone chain while sliding the elbow back and forth. Next one is Stretchy IK. You can see this here, and we can turn this on and off if we want to as well. So actually I'll just put that back to 0. we go. So, Stretchy IK works by proportionately moving the lower arm and the wrist relative to the distance between an object which is positioned at or controls the upper arm and an object which moves the wrist, such as an IK handle control object, when the distance between the two objects is greater than the original chain length. So in other words, we have an object which controls our IK handle. It's regular IK until we get past a certain point, and then the chain will become the distance between this point here, which is positioned at the upper arm, and the actual control object for the IK handle. And this is again working off of translation. So when the object is at the correct distance, this joint will proportionately move in the x-axis, as will the wrist. Okay. So next is the non-stretchy soft IK. So you can see how that works there. And of course we can always increase this value to something like 0.5 to emphasize the effect. And let me get up this text. So non-stretchy soft IK works by offsetting the IK handle from a control object so that as the distance between the upper arm and the control object approaches the length of the bone chain, the IK handle will begin to lag. So even before the distance between the control object and a point at the upper arm reaches the length of the chain, this IK handle will begin to lag, and that's what gives you this sort of soft IK feeling. If we were to turn this off, we just get regular IK, and you can see it there. But if we put this up again to 0.5, you can see how the IK handle is lagging behind the control object. Next we have the stretchy soft IK. So instead of making the IK handle lag, Stretchy Soft IK controls the length of the bones by using an exponential function to stretch the bones before the IK control object moves further away than the length of the chain. After a certain distance, Stretchy Soft IK reduces to ordinary Stretchy IK. And this effect, just as with the Stretchy IK, nothing happens if the distance between a point at the upper arm and the control object is less than the distance of the original chain. It only works when it approaches the distance of the chain and goes beyond. So you can see that the chain doesn't look like normal Stretchy IK, but then after a while it's just Stretchy IK. Now I set this chain up specifically so that the length of this upper section was 30 and the length of this lower section was 40. What that means is the lower arm in parent space has an x value of 30, or I beg your pardon, 3, and the wrist here has a length of 4, or a distance of 4 in x. And you'll notice that if I put this close to something like, actually that'll probably be fine, you'll notice that even before this object is at a distance greater than the chain, these joints are already beginning to increase in value in parent space, and that's what's giving us that soft feeling. Again, if I just put this to something, I think it was 9, something like that, doesn't matter, 9.91 will do. If I turn this off, you'll notice the bones, or the joints, move back. Again, it was 0.2, you can just see them move up slightly. The reason they're moving up is because they're increasing in length, so this chain has to go up like this. so that the wrist is fixed at the IK handle. Okay, and lastly we have IK pinning. So I'll just show you how it works. Oops, let's just turn it on. And you can see there. So elbow pinning is similar to Stretchy IK, but it works on a per bone basis rather than on the entire chain. This process requires the creation of another object for distance calculations. If this newly created object is used in a pull vector constraint with the IK handle, then the lower arm will appear to follow its world space position. Now I have a feeling I didn't actually do a pull vector constraint on this, so let me just do that now. There we go. So now if we select this IK handle and move it around, you can see it appears at this point is controlling the world space position of this lower joint here. And similarly to the other setups, it only works if the distance between these objects is correct. So if the distance between this object and the one at the positioned at the upper arm is less than the original length of the upper arm, then nothing happens. Then as soon as it's past that, then we get the pinning. Okay, so that's just an introduction to everything that we're going to cover, and sort of a formal description of the effects we're going to create. So in the next video we'll actually get started with creating our control rig.